Good afternoon, class. We are looking at exam 3 review, covering chapter 3, differentiation rules, chapter 4, application of differentiation. This exam covers section 3.9 to 3.11 and 4.1 to 4.5. Here's the first part covering section 3.9. 3.9, related rates. That's what we are covering. First, reminding everyone of many differentiation formulas we discussed, from the definition to basic differentiations to the product rule, quotient rule, composite function resulting in the chain rule, trigonometric inverse functions and their derivatives, logarithmic functions and their derivatives. We should be comfortable with those. So here's in essence the application that we are going to move on, and here's reminding you of the definition of E. So 3.9, related rates. If we are pumping air into a balloon, both the volume and the radius of the balloon are increasing, and the rates of increase are related to each other. But it is much easier to measure directly the rate of increase of the volume than the rate of the increase of the radius. So in a related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another one, which may be more easily measured. So the procedure is, number one, find an equation that relates the two quantities. Number two, use the chain rule to differentiate both sides with respect to time, which means now the independent variable is t, and any other variable you come across is a dependent variable. Therefore, dy dt, that means t is the independent variable, equals dy du dt according to Leibniz's notation. A spherical balloon is deflating, meaning losing 8 cubic centimeters of air per minute. At the moment when the radius of the balloon is 20 centimeters, how fast is the radius decreasing? Here's the hint. You're supposed to know the volume. The sphere looks like that, and the volume of a sphere is 4/3 pi r cubed. I'm just reminding you right now. You're supposed to know that the volume is 4/3 pi r cubed. So related rates are basically word problems. When it comes to word problems, you write the given. First and foremost, we have this piece of information. The volume is 4/3 pi r cubed. So what is this piece? The units pretty much tells you this is dV dt, and losing means minus 8 cubic centimeters per minute. dV dt is negative 8 because it's losing air. Cubic centimeters per minute. We are interested in finding how fast the radius is decreasing. How fast, that means rate. So we want dr dt. At what point? When the radius or r is 20 centimeters. This is translation into math. So we are going to differentiate this with respect to t. Volume is a function of radius, and both of them are functions of t. Pay attention to this. T is the only independent variable. So you want dv dt, and first and foremost, notice 4/3 pi is just the number. So dv dt is 4/3 pi, the number. Now times r cubed, 3r squared dr dt. R cubed, 3r squared. If r was the independent variable, you would be done because r is a function of t times dr dt. This is by the chain rule. That means 4 pi r squared dr dt. Now, what is r? Replace it, 20. What is dv dt? Replace it, -8. What is dr dt? We are going to find it. So we are going to divide both sides by 4 pi times 20 squared. Obviously, this is 400 times 4 pi, 1600 pi. We're going to divide by 1600 pi. -1/200 pi. Units of the radius over the units of time, centimeters per minute. If you work it out, you put this one with its units, cubic centimeters per minute. You put this one, 20 squared means centimeters squared. You see that it results in the proper units. This is an exact answer. Roughly, you put it into the calculator and you carry a lot of decimals depending on the question, how many decimals they ask you. If they don't ask for the decimal, this is the answer. Okay, and you're done. If they do, make sure you always, in your work, write the exact answer and then approximate it accordingly. A 20-foot ladder leans against a building. The base of the ladder slips away at a rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. Always draw a setting. So here's the building, here's the ladder. It's moving this way. Resulting in this shape, which is a right triangle. As x moves this way, y goes this way. So we're going to call this x, we're going to call this y. You can call it anything you want. So what's going on as it, and this one is fixed at 20 feet. So the hypotenuse is fixed at 20 feet. As it moves this way, it moves at a rate of 2 feet per minute. As it moves this way, it comes down at a speed or rate of dy dt. We want to find that. So that's the setting. We're going to read this one more time. So that means this is c equals 20. That means dx dt is 2 feet per minute. And that means a squared plus b squared is c squared, Pythagorean theorem. So you're relating x and y, x squared plus y squared equals 20 squared. A squared plus b squared equals c squared. Pythagorean theorem says x squared plus y squared equals 20 squared.
And
Go ahead.
professor,
Yes, go
sorry.
ahead.
Are you able to, do you have to draw it to know how to solve it?
Yes.
Or is there a way like you don't
No,
you
you
don't have
have to draw.
to
You must
draw?
draw because you have to
Okay.
define your variable. So if I said a squared plus b squared equals c squared, and then I have x and y here, it makes no sense. You have to draw, letting yourself and your reader know this is x, this is y, or call it anything you want, and this is c equals 20. It can't be done without the drawing. Must be drawn.
Okay.
All right, sure. So now x squared plus y squared equals 20 squared. So what are we looking for? dy dt. At what point when the base is 12 feet, when x is 12 feet. So dx dt is given 2 feet per minute. The setting tells you Pythagorean theorem, x squared plus y squared equals 20 squared. The setting tells you you're looking for dy dt when x is 12. This is the translation of the situation, and you need the drawing to figure out this formula. X squared plus y squared equals 20 squared. All we have to do, differentiate this with respect to t. T is the independent variable. X squared gives us 2x dx dt plus y squared gives us 2y dy dt. Any number. We know this is 400. And it doesn't matter whether we know it or not. It's a number. The derivative is 0. Now, as you look at this formula, you have the x, you have a dx dt. You're looking for dy dt, but you don't even have the y, and therefore you have to go to this equation, replace the x with 12 to find the y. So x squared plus y squared equals 20 squared. 12 squared plus y squared equals 20 squared. Subtract 144, you get 256. You take a root, and y is 16 feet. Now we are ready to replace everything except the missing dy dt. 2 times 2 times 12 is 48, 2 times 16 is 32, and so dy dt is negative 48 divided by 32, which is negative 3 halves feet per minute. What I want you to notice is this: x is increasing, dx dt must be positive. Y is decreasing, dy dt must be negative, and it is. We are going to look at the same question. A 20-foot ladder leans against the building. The base of the ladder slips away at a rate of 2 feet per minute. However, in this case, we want to find the rate of change of the angle between the ladder and the ground when the base is 12 feet. So not only the height is changing, and therefore the rate of the moving height is changing, Also the angles, and both angles, by the way, I'll discuss both angles in a moment. So again, we have the same situation, moves this way, creates this shape, a right triangle. As x moves to the right, y moves down. This is the angle between the ladder and the base. And again, it's very critical because one may think this is the angle, which is the angle between the ladder and the wall. That's why the setting, the drawing is a must. You're telling your reader and yourself, when you go back to the same question sometime later, you may forget that what is it that you are working on? As it moves this way, it creates speed for x dx dt equals 2 feet per minute. As it moves this way, theta changes. So what is d theta dt? If you call this, let's say alpha, alpha is also changing, everybody, but that's not what we want. We want d theta dt. So again, the information from the previous page is not going anywhere. We have all the information from the previous page. The only difference is now we want d theta dt. That is the difference between the previous page and this one. Now, generally speaking, you want to find a way to relate the quantities that can give rise to the answer. And in this case, you want to relate the quantities x and theta. So reminding everyone of the concept of a sine theta, which is the opposite y of a hypotenuse 20, and cosine theta, which is the adjacent over the hypotenuse, or x over 20. You have both of them. Although we have the value of y from the previous calculation, you always use the known data. So we are relating x and cosine theta, and which will result in d theta dt. So we are going to look at this one. We're going to differentiate that. And to differentiate that, cosine gives you negative sine theta d theta dt. So negative sine d theta dt. The right side, I want to make sure that we recognize this one as 1 over 20 times x. So 1 over 20 times dx dt. Now, when we look at this, we have dx dt. We have 1 over 20, that's good. We are looking for d theta dt, but we don't have the sign either. So minus sine theta. However, we remember that in order to get to y, we've already calculated it in the previous page. So we're not going to recalculate. Y is 16. Replace it here, and you have your sign. So you're going to say minus, this negative sign remains, sine theta, 16 over 20, this is sine theta, everybody, d theta dt, and 1 over 20 times 2. 1 over 20, dx dt is replaced with 2, And both sides have the same denominator. You can drop it. So d theta dt is negative 2 over 16. Negative 2 over 16. Why negative? Because one side is negative, class. Negative 2 over 16 is negative 1 over 8. Units, radians per minute. The angles always have the units of radians when it comes to calculus, unless otherwise mentioned. It's always in radians, everybody. So very straightforward. We're going to move on, everyone, to the next question. Example, for falling sand is forming a cone-shaped pile. The volume of a cone is increasing at a rate of 54 pi cubic inches per minute. The height of the cone is twice the radius of the base. Find the rate at which the radius changes when the radius is 6 inches. First and foremost, a cone looks like this. We should know that. Secondly, the volume of a cone is 1/3 pi r squared h. We should know that. So those are information from algebra, geometry, you name it. So that's the first thing, we should know that. So let's read again and write the given symbol. So the volume of the cone is increasing at this rate. That means the speed, that means the derivative. So dv dt is this much. 54 pi cubic inches per minute, dv dt. Again, remember, the volume has this formula. The height is twice the radius. H equals to R. H equals to R. Find the rate at which the radius changes. That means dr dt. Find dr dt. At what point? When R is 6 inches. This is the translation of this question. And this is the formula that we are supposed to know. And so all we have to do, differentiate this, and we are in good shape. So the volume, if you want to differentiate this, please understand you have two variables. You have three variables, V, R, H, and all of them are dependent. Depend on what? Depend on T. T is the independent variable. So dv dt, if I want to differentiate that, I have to go with dv dt. However, because I have two variables, I have to use the product rule on that. But to make life easier, H equals to R. Which one do I solve for? Do I solve for H or do I solve for R? Because I want dr dt, I'm going to replace the H with 2R. If the question is asking for dh dt, then I'm going to replace the R with H over 2. So dr dt, I'm going to replace the R. I'm going to replace the H with 2R. H with 2R. And so now I have 2/3 pi r cubed, 2/3 pi r cubed. Now I want to differentiate this with respect to t, and I have only one variable r on the right side to worry about. I don't have to worry about the product. So if I want to differentiate this, please recognize 2/3 pi as a number. So dv dt is 2/3 pi, and all I have to do differentiate r cubed, 3r squared dr dt, 3r squared dr dt. This one is by the chain rule. And so maybe it's hard to see. You drop the common factor of 3 from the numerator and the denominator, you end up with 2 pi r squared dr dt. And now all you have to do, replace it. What is dv dt? 54 pi cubic inches per minute. What is r? 6. And find the missing dr dt. Of course, this is 36. And times 2 is 72. So you have 72 pi dr dt. We are going to divide both sides by 72 pi. And we get 54 over 72. They are both divisible by 18. We get 3 over 4 inches per minute. Units of the numerator here, radius, over the units of the denominator, t, dr dt. Think of it that way. And we end up with 3/4 of an inch per minute. When the volume is increasing by this much, okay, the radius is increasing by 3/4 of an inch per minute. Example 5, at noon, ship A is 150 kilometers west of ship B. Ship A is sailing its east at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? Definitely, we need to do the drawing to have a better understanding as to what's going on. So what happens at noon? At noon, let A sub 0 be the position of ship A, and let B sub 0 be the position of ship B, and they have a distance of 150 kilometers. And this is moving this way, this is moving that. This is moving this way. A is moving at a 35 kilometers per hour, going to the right or east. B is going up or north at 25 kilometers per hour. So A moves east at 35 kilometers per hour, and let X be the distance traveled by A. Similarly, B moves north at 25 kilometers per hour. Let Y be distance traveled by B at time t. So this is the distance traveled by A. This is the distance traveled by Y. The total distance from here to here was originally 150, which makes this one, if this is X, this makes this one is 150 minus X. We're going to call this distance Z. So this is X, this is Y, this is 150. Therefore, this becomes 150 minus X. dx dt is 35. dy dt is 25 kilometers per hour. A has sailed east. The remaining distance to B0 is 150 minus X. So you have dx dt, you have dy dt, and at 4 p.m., t equals 4, we want to find dz dt. So draw the setting, understand the process. dx dt is 35 kilometers per hour. dy dt is 25 kilometers per hour. We want to find dz dt at which point? 4 p.m. Now, why is T4? Because at noon, everybody, from noon to 4 p.m. So T equals 4. 5 p.m. T equals 5. 8 p.m. T equals 8. So from noon to 4 p.m. That's how we find the T. So it's pretty straightforward. And now, of course, we use Pythagorean theorem, a squared plus b squared equals c squared. So this distance, a, 150 minus x quantity squared. This distance b plus y squared equals this distance c, z squared. So we did all of this explanation, all of these drawings to create this equation. In other words, if you just put this equation, one wonders how you got that. Set up the drawing. And now we're going to differentiate. We are differentiating with respect to t. T is the independent variable class. Even the derivative of x is dx dt is not 1. The derivative of y is dy dt. The derivative of z is dz dt. Therefore, this one is 2 times 150 minus x to the power of 1 times the derivative of the inside is negative dx dt. This is 2y dy dt. This is 2z dz dt. I want to make sure we understand what happens here one more time. This is easy. 2y dy dt. This is easy. 2z dz dt. This one, 2 times 150 minus x to the power of 1. The derivative of the inside is negative dx dt. Negative dx dt. So you want to be very careful that this one is done properly. So we are going to plug in. What can we plug in? Just about everything. We want to plug in x. Well, what is x? After 4 hours, x is 4 times dx dt. What is y? After 4 hours, y is 4 dy dt, right? So at 4 p.m., x is 4 times 35, which is 140. Y is 4 times 25, which is 100. And the units, kilometers, because these are kilometers per hour. Okay, we are in good shape, but we don't have the z either. Well, put it into this formula. What do you put into this formula? X is 140, y is 100, and z can be found. So you put 150 minus 140 squared plus 100 squared equals z squared. And I hope you recognize this as obviously 10. When you square it, you get 100. And this one, you have two zeros, you add two more zeros. And z is the left side, take a square root. That is the square root of 10,100. Again, I hope everybody's okay with that. Now, let's plug in. 2 times 150 minus x, we said x is 140. Minus dx dt, we said it's 35. So negative sign remains, minus 35. Plus 2 times y, we found it to be 100, times dy dt, which was 25. And on the right side, 2 times z, which is this number. And we're going to keep it as that for now. And then dz dt is missing. Notice this is 2 times this is 2 times this is 2 times this. You can drop all the 2's, okay? And so this is 10. 10 times negative 35 is negative 350. And this is just 25 with two zeros. That means 2,500. So you have negative 350 and 2,500, which is basically $2,150. And so dz dt is 2,150 divided by this number. And now use a calculator. And we go with one more decimal because they are given with the whole numbers. We just go with one more decimal, 21.4 kilometers per hour. If you have doubts, you have to put more decimals, but that's how you come up with the answer. And I hope you can see that why, more importantly, why we go through the process of showing this, because we can't come up with this equation without having this drawing. A spotlight on the ground shines on a wall 12 meters away. If a man 2 meters tall walks from the spotlight towards the building at a speed of 1.6 meters per second, how fast is the length of his shadow on the building decreasing when he is 4 meters from the building? 1 meter is about 3.3 feet roughly. So here's the spotlight, and the man is moving towards the wall, and you want to describe the situation, draw the setting. And this distance is 12 meters. So from here to here is 12 meters. Over here is the spotlight, over here is the wall, and over here somewhere is the man. So The man is moving this way, away from the light. So the light is here. The man is moving originally right, starts from here and moves. And here's the wall. As the man moves, okay, starting from here, it creates a shadow. And the shadow, as it gets closer and closer to the wall, okay, the shadow changes its height. So as it gets closer and closer, for example, if it's here, goes like that, just for the sake of argument. If you put it here, goes like that. And what happens is that if this is x, this is 12 minus x, and the shadow is decreasing, by the way. So when the man covers x amount, the shadow has a height of y, and if this whole distance is 12, this must be 12 minus x. And so when the man covers x feet, its speed is dx dt. So dx dt is 1.6 meters per second. dy dt, when 12 minus x equals 4 feet, because it says how fast is the length of his shadow on the building decreasing when he's 4 meters from the building. This distance, 12 minus x, is his distance from the building at any given moment, given x. So this distance is equal to 4, which results, of course, in x being 8. So this is the synopsis of what's happening: description, drawing, and now we can come up with a formula that will help us answer the question. So we are dealing with a small triangle and a large one, similar triangles. This small one and this entire one are similar triangles. Here's the definition I want to remind you of similar figures. In the case of similar figures, two figures are considered similar if corresponding angles are identical, that means they're equal. Corresponding sides are in proportion. So how do we know the small one and the big one are similar? Because this is a common angle. This is 90 degrees. That means the other ones must be the same. Or you can say these two lines are parallel, and that proves that they are similar. So if they are similar, we can say that this side from the smaller one, this side from the bigger one is the same as this side to this side, from this side to this side. So one way to write this, y is from the big one, 12 is from the big one. Corresponding to y, 2 is from the small one. Corresponding to 12, x is from the small. This is not the only way to write that. You can write x from the small one, 12 from the large one. X from the small one, 12 from the large one. Equals 2 from the small one, y from the large one. And it's important to see that what I wrote here, the cross product is the same as the cross product here. So there are several ways, several different ways you can set this up. Okay, everybody? So whatever you're comfortable with, stick with that. Now, remember what we have. We have dx dt and we want dy dt. All you have to do is solve for y. So to solve for y, we can multiply the 12 by 2 and keep the y. I hope you, let me write this. So y times x is 2 times 12. So basically divide by x, you get y equals 24 over x. This is elementary algebra class, you know that. So y is 24 over x, and we are going to rewrite it as 24x to the power of negative 1 for the sake of differentiation. So we're going to differentiate both sides with respect to t. This becomes dy dt, and this becomes 24 times negative 1 x to the power of negative 2. Let's do that too. So this is dy dt is 24 times negative 1 x to the power of negative 1 minus 1 minus 2. And again, we would be done if x was the independent variable, but it's not. That's why you have dx dt. And so negative 24 over x squared dx dt. Again, I'm going to erase my work. Negative 24 over x squared h squared times dx dt 1.6. 24 is divisible by 8. So you get minus 3 and you get 8 here. I hope you recognize 1.6. Imagine it was 16 divided by 8 would be 2. So this is 0.2 when they cancel each other. And 0.2 times negative 3 is negative 0.6 meters per second. The units of y over the units of t, which means what's happening to the length of his shadow? The length of his shadow is decreasing at the rate of 0.6 meters per second. Meters per second as he moves this way, gets closer and closer to the wall, just for the sake of argument, so you see what happens. If the guy is here, right? So this is definitely smaller than y, okay? And it makes a perfect sense. A cylindrical tank with radius 10 meters is being filled with water at a rate of 7 cubic meters per minute. How fast is the height of the water increasing? Draw a diagram, include units. Always draw a diagram. So here's the diagram. Here's the fixed radius equals 10 meters. They may not even give you the radius and they want you to, solve it in general. You have to recognize the radius can't change. It's fixed. because of the shape, cylindrical shape, okay? And also, let's see what's given symbolically. We should know the volume of a cylindrical shape is pi r squared h. So that's a piece of information from algebra, geometry, you name it. So the volume is pi r squared h, and what is given? Capital R is 10 meters, and it's being filled with at the rate of this much. So this is dV dt. Even the units, cubic meters per minute, should tell you that it's dV dt. dV dt is 7 cubic meters per minute. How fast is the height? The h dt is missing. I'll quickly show you two different ways. First, understand that R is fixed. R is fixed, everybody. When R is fixed at 10 meters, if you want to differentiate this, dV dt gives you pi r squared, which is fixed. Pi is a number, R is a number, times h, dh dt, times h, dh dt. And so now this is 7, R is 10, so 7 is 100 pi dh dt, divide by 100 pi, and this is your exact answer. I'm going to keep it as that. The h dt is 7 over 100 pi meters per minute, units of the height over the units of time. Or right here, class, if you change the r to 10, 10 squared is 100, so you can write this as 100, okay, 100 pi h, this one, 100 pi h. And now if you differentiate is 100 pi times dh dt, so dv dt is 100 pi times dh dt, which is the same as what we have here. Again, you can keep the r because they may give you r at different values or even give you r as a fixed value, okay? And then you can figure out dh dt as a function, functional value of the r. It could be given in that form. If the minute hand of a clock has length r in centimeters, find the rate at which it sweeps out area as a function of theta. Area as a function of theta. So here's a circle, here's the radius r, here's the angle theta, the central angle theta. When that happens, everybody, it subtends an arc S equals r theta, and this one sector has an area half of r squared theta. I hope you remember that from trigonometry, pre-calculus, you know. So I'm reminding you that this arc has arc length. This is called the arc length, r theta, and this sector wedge has this area half of r squared theta. So what do we want? Well, a is 1/2 r squared theta. dA dt is of interest to us where r is fixed because you're looking at the length r. You know, the length doesn't change when it comes to a clock, and it's, you know, minute hand, hour hand, makes no difference. None of them changes anyways. So we are interested in the minute hand, of course. So, and they want us to find this just the way it's given as a function of theta. Theta is not even given. So dA dt. So if you want to differentiate this, remember r is fixed class. R is a number and it's not given. So half of r squared. dA dt is half of r squared. Now theta gives you d theta dt, d theta dt. And that's important to understand. And believe it or not, you're done. However, what I want to do, I want to give you a couple of examples to make some sense out of this. For example, in 1 hour, what happens? The minute hand covers a complete cycle, 360 degrees or 2 pi radians. So in 1 hour, we covered 360 degrees or 2 pi radians. So d theta dt is 2 pi radians per hour. So we are going to replace d theta dt with 2 pi. So half of r squared times 2 pi. The 2's cancel out. We get pi r squared centimeters squared per hour. In this case, we are assuming the units in centimeters, right? Another example, what happens in 1 day? 1 day covers 24 hours. Each hour covers 2 pi. So over the course of 24 hours, it has a complete revolution. How many times? 24 hours. I'm talking about the minute hand. Pay attention to the minute hand, everybody. So 24 times 360 degrees or 24 times 2 pi radians per day. Radians per day. So we are going to replace this guy with 24 times 2 pi. 24 times 2 pi. So if I put 24 times 2 pi here, I can cancel out the 2's from the denominator and the numerator, and I get 24 pi r squared. 24 pi r squared centimeters squared per day now. This was per hour, this is per day. The number of revolutions. Example 9. A street light is mounted at the top of a 15-foot tall pole. A man 6 feet tall walks away from the pole with a speed of 5 feet per second along a straight path. How fast is the tip of his shadow moving when he is 40 feet from the pole? Definitely, I need the drawing. So it looks something like that. Here's the pole, 15 feet tall. Here's the light. Here's the man, 6 feet tall. And he is moving at this speed, 5 feet per second, going this way. So let's explain the situation. This is the tip of the man's shadow. Remember, the man starts from here, okay, and moves. When the man covers X feet, its shadow covers Y feet. Dx dt is 5 feet per second. The man moves at 5 feet per second. That's the speed. Dy dt is missing what we are looking for. At which point? When he is 40 feet from the pole, when this distance is 40 feet. So that's understanding the situation. Now, we do the drawing again here, and we recognize that the small one and the large one, the small and large triangles are similar triangles. And so if this is 6, this is 15. If this is x, this is y minus x. So the small one, for example, 6 to the large one, 15. The small one, y minus x to the large one, y. This is one way to write the idea behind similar figures. Again, this small triangle and the entire one, the large one, are similar. I hope it's clear to everyone. Cross product. 15 times y minus x equals 6 times y. Which means 15y minus 15x equals 6y. Move this one this way, make it negative 6y, and move this one this way, make it positive 15x, and you get 9y equals 15x. And therefore, division by 9 results in 15 over 9 being 5/3, y equals 5/3 x. Differentiate with respect to t, both sides. This gives you dy dt. This gives you 5/3 times dx dt. So all you have to do, replace the dx dt with the given value of 5, and that gives you 25/3, same unit, feet per second. Feet per second. That means the man is moving away from the pole at a speed of 5 feet per second, and the shadow is moving and the speed is changing. At the moment when this distance, the man is 40 feet from the pole, then this is the speed of its shadow, 25/3 feet per second.